Okay, so this is a quick video that can help with exercise 9D question 15. I'm not going to do your question, I'm going to do a similar question, and hopefully you can use the same kind of thinking to successfully respond to the question that you have. So we're told that while in a car, Harvey measures the time between lampposts. So as he's driving along, how long between one lamppost and the next. 2 consecutive times were 1.2 and 1 seconds. And he finds that the distance between each lamppost is 30 meters. Now he wants to find, we want to find the acceleration of the car and its speed as it passes the first lamppost. So that's going to be the initial velocity. Okay, so in a situation like this, I can recognize that there's not a lot of information. I don't know its velocity at any of the points in the journey. I know it has acceleration and it's constant, and I know some distances, and that's just about all we know. This is the kind of situation where I need to try and make some of my variables double up as much as possible. So I'm going to take some variables for the first part of the journey, in between the first 2 lampposts, and also take some for the whole journey, so from lamppost 1 to lamppost 3. Now there's something clever that's going to happen here. Let's collect these variables. I know the displacement is 30. The initial velocity is unknown, but I'll call it u. I don't know v. I don't think I'm going to work with that. The initial acceleration is a, well, it's the constant acceleration, and the time for that part of the journey is 1.2. Thinking of the entire journey, the displacement is going to be 60. That's 2 lots of 30. The initial velocity is still the speed at the first lamppost, so it's still going to be u. Final velocity is unknown. And once again, the key here is that constant acceleration. Throughout the whole journey, the acceleration is a. The time for the whole journey is going to be 2.2. Okay, the aim here, the reason this is going to work is because I have the variable or the value u in both of these sets of SUVAT variables. I have an unknown acceleration, the value a, in both of these sets of SUVAT equations. I hope you can see where I'm going. We can generate simultaneous equations. 2 different equations that contain the variable u and the variable a. Let's go ahead and see what we can do. So I'm going to choose the SUVAT equation that works best with the variables we're working with. We'll use s equals ut plus half at squared. Substituting in, we get 30 equals 1.2u plus 0.72a. As we move on to the variables for the entire journey, we get 60 equals 2.2u plus 2.42a. These are the equations that we'll use as our standard simultaneous equations. Now, there's lots of techniques that you can use. You can try to eliminate, you can use rearrange and substitute. Whichever techniques you're comfortable with, go ahead and use. Some of you have the simultaneous equation solver on your calculator, and that might even be what you do here. Either way, solving these simultaneous equations, you get solutions a equals 4.55 and u equals 22.27. The initial velocity at the first lamppost was 22.27, and the acceleration all the way through the journey was 4.55. With these values, we should be able to go back and find final velocities for any of the lampposts. So, spotting that we didn't have a lot of information, using part of the journey and all of the journey so that some of the variables overlapped each other, allowed us to generate simultaneous equations, and we're all phenomenally happy to work with simultaneous equations and solve from there. So just look out for this sort of question and use this strategy as needed.